Excellent, thank you. So I'm going to talk to you today about some of the efforts that are going on, and they're primarily Forest Service focused. And we have a lot of collaborative partners. And Dr. Mark Brisberg and I gave a presentation. So for NOAA and then the National Coordinated Soil Moisture Monitoring Network. So you will recognize some of these slides if you attended that webinar. So I'm not really going to go over these projects, but I'm going to tell you some of the challenges and potentials. So RAWS, you can see the distribution of the remote automated weather stations across the country. And people, now that their attention is drawn to RAWS, are trying to figure out what is really RAWS, what is that, who owns it, who operates it, who do we talk to if we want to gauge in the RAWS system? Good question. It is a multi-federal and state program. It is operated from something called the Depot and NIFC, the National Interagency Fire Cooperative. So we know that RAWS is out there. We know that they're in forests, but are they truly in forests? So one of the challenges is they're not really in forests. They're in an open area in a forested setting. But what they are doing is providing data in that forested ecosystem. So they are giving good information for a fire assessment, but they can also give us additional information because we know that drought affects soil moisture and leads to a deficit and then leads to fire. And we're also knowing then there's other biofeedback loops to that and other physical feedback loops to that when we finally do get precipitation. But RAWS is one of the main tools that informs the National Fire Danger Rating System. And there are not soil moisture sensors on RAWS across the country. There's about 2,200 stations, and maybe I'm going to be generous and say 200 of them have soil moisture sensors on them, but that's being so generous. But we're changing that. The other thing, RAWS historically used GOES. And it uses GOES, but then it went to WIMS. And my apologies, I cannot never remember what WIMS means, but I don't need to anymore because now it goes to FEMS. And FEMS is the new wildland fire application. It's the Fire Environment Mapping System. And this is open to the public. Everybody has access to it. And we were successful, our team within Forest Service and working with the Depot and BLM and the other partners in getting the ability to attribute characteristics of all the RAWS stations across the country, providing basically metadata about each site location. What is the soil type? What is the slope position? What is the ecological land type association where these are sitting? What's their aspect? And that's to encourage that when modelers use the RAWS data in the upcoming future, that they also there have that ecological data right at their ability. And so one of our other products, people this week have been hearing me really talk about TopoFire and the efforts around TopoFire and putting you in contact with one of our speakers later today, Zach Holden. He'll be on a panel who is one of the authors of this model. Well, it's a newer model that looks at fire patterns and behavior and uses soil moisture data. We need more raw data to be able to feed those models to ensure that as we use remote sensing data, that we have good calibration and validation. So TopoFire is something that we're hoping that everyone looks at and engages with and sees if it's a little bit more useful. So that way we get soil moisture in our National Fire Danger Rating System. And there's a very nice webinar describing the whole TopoFire that Zach gave on the November 16th, 2022 recording on drought.gov. And you heard Claudia Cotton speak with us. Well, that's another one of our pilots. It's one of the first mesonets within a national forest. Now, this does get your soil moisture sensors under the canopy. And it's been really challenging to do that. I mean, it's taken so much effort, but at least we're starting to look at the protocols and methodologies about how to put these sensors under the canopies. What are some of the problems? You've got core teams working on this. You've got a forest soil scientist and a forest hydrologist overseeing this effort, starting to be able to be subject matter experts on how to do this. And then you have a entity like the Kentucky Climate Center right there to answer your questions on the other side. How does this data look when it comes in? How does it look as it portrays that area of the state? So we are doing that. We are facing this challenge head on. And that's with the support of NOAA as well. Okay, everyone, from about once a week, I get a question. Somebody says, well, let's ask Stephanie. Well, the truth of the matter is Stephanie does not do research. Stephanie does not put soil moisture sensors in the ground anymore. That was 20 years ago. Stephanie is the person who says, I know who can answer that question for you. So I go find those people to do that. And we have a wonderful project with our National Technology and Development Program under the leadership of Dr. Catherine Zarn and Dr. Mohammed Nash that are looking at the different sensors and how they behave in forest soils and testing them in various test beds in Alaska and other places on the National Forest System lands. We have pilots, and they are giving feedback as how these sensors perform in these various forest soils. And that publication will be pending here in probably like a year or two. And so here's another really nice project. This is our next frontier. We started in the east and now we're moving west, and we're working with NRCS on this funding and Dr. Skye Wills and her team. So this looks at the rain on snow events and also the snowpack influence and what's the fate of melting snow water and how that influences soil moisture. So we've got projects in the Salt River Basin at the Sierra Ancha Experimental Forest under the leadership of Dr. Jackson Leonard and Dr. Sally Diamond with Northern Arizona University. And you'll hear her speak this afternoon about some of her modeling efforts. And then there's citizen science, and you'll hear Peter Goebel talk to us a little bit about this later. But this is an additional citizen science project that was recently funded in the Yampa Basin in Colorado on one of our national forests. And we talk about forest soil moisture monitoring, and we always talking about sensors. But what we've come to realize is that citizen science can also help us with ocular monitoring and looking at conditions in remote areas and places that people are familiar with, and recording that data and helping that to inform the changes that are going on out there in various remote locations. Because again, that is a challenge that we face with forest soils. There's no one around. These are our remote areas. They are our protected areas. They are at high elevations. They are hard to get to. There is not a road. There is not infrastructure. And so where we need to know this information in our headwater systems, I mean, it is a challenge and a half to be able to get equipment in, maintain that equipment. But so citizen science could very well be one of our answers to that. And this is our Cocoa Ross project with Peter and our partners in Region 2 in Colorado, Donna Chirac, our climate collaborator there in the regional office. And we're about to launch that in a pilot with as we talked a little bit later about our state forest service in Colorado. It's a wonderful partnership, and they're going to pick this up and be able to utilize that as they go out and look at state lands and private timberlands. And then there's our coastal systems. This is our project at Santee Experimental Forest. And thank you, Devondra, for providing this beautiful slide for us to look at your paired watershed study. And so there's really good information coming out of our coastal areas and how soil moisture in coastal zones is changing over time. And Devondra's had a wonderful relationship with NRCS. He's been able to get them out there to look at soil mapping, potentially put in a new scan site. And he is now uploading his data in cooperation with Stephen Coring's National Soil Moisture Database, the online, where all of us have an opportunity to store soil moisture data. And then this is another one of our NRCS collaborative projects that our ORISE fellow, Dr. Carlos Quintero, oversees for us in his project. And he developed this slide for me today, just to give you an idea of what it is we're looking at when we talk about these soil water balance models. When we are testing models, we're installing, we have gauge watershed data that we can look at, extrapolating soil moisture data back onto the landscape. And Carlos is going to talk about this later. So here's some additional projects. We're to the point now where I am seeing the interest in soil moisture monitoring in forests increase every week. We have and we have problems, we have challenges, and I really want to talk about the challenges. When we want to do soil moisture monitoring in national forests, it's not just about going out there and doing it. We have to get the collaboration of our decision makers and line officers. And right now we do not have capacity to be able to do everything we want to do. Money is not always the problem. So we try to leverage, we try to hope, but we are on board now for retrofitting RAWs in Texas, Alabama, Missouri, Louisiana, Wisconsin, South Carolina, and California. I mean, that could be a huge change within the next year. We've purchased over $150,000 worth of soil moisture sensors, of Stevens soil moisture sensors for the RAWs. And we hope to see those all installed within the next year. And then we also know that we have some really excellent research studies going on in a Rocky Mountain Research Station area with Chuck Rhodes and his work and follow-up fire research in the Poudre River watershed in Colorado. So it's happening, and every week somebody reaches out to me and says, hey, I'm doing this forest soil moisture work. What can you tell me? What do you know? So you are my resources. You are the people that will answer those questions, not me. So you will be hearing from me in the near future with a question that I know you will be able to answer. And here's my special thank yous. I could not do what I do if I didn't have the support of particularly Dr. Andy Coulter, our National Soils Program Lead. And he works on the National Forest Service system side of our agency, and he works to get funding and collaborative support across the country through our national forests to support this. So thank you, everyone. And with that, let's hope that we can get Stevens back up. Yes.